BYD has built more than 7.7 million plug-in hybrids since 2008, and inside its biggest factory, a finished car rolls off the line every 30 to 60 seconds. Not every hour, every 30 seconds. And here's the twist most people miss. BYD isn't beating Toyota and Tesla with a better battery. It's beating them with a gasoline engine, one it designed itself. And the reason that works is the exact opposite of what you'd expect. Before we get into it, make sure to subscribe to the channel so you can watch videos like this before anyone else. Everybody's been arguing about whether hybrids are a dead end or a bridge. And while that argument was happening, BYD quietly built a hybrid system that outsold its own electric cars in some months, and built the manufacturing machine to produce it at a scale nobody else can currently match. So here's what this video covers. We're going to figure out how a company that stopped building pure gasoline cars entirely ended up perfecting a gasoline engine. We're going to walk through exactly how a DMI powertrain gets built, and how it actually works on the road. And this is the part that matters even if you never buy a BYD, what its cost structure does to the price of every hybrid and EV you'll be shopping for. If that's useful, hit like. It genuinely helps this reach more people. To understand why BYD's hybrid works the way it does, you have to go back to a decision the company made almost 20 years ago, long before anyone considered it a serious threat to Toyota. In 2008, BYD launched the F3DM, the world's first mass-produced plug-in hybrid car. Not Toyota's, not a European luxury brand's, a Chinese company most Western buyers had never heard of, releasing a plug-in hybrid a full decade before plug-in hybrids became a mainstream category. And BYD didn't come to that from a car background. It started as a battery manufacturer, which turns out to be the single most important fact in this entire story, because it means BYD approached the hybrid problem from the electric side first and treated the gasoline engine as a supporting component. Every other legacy automaker did the reverse. They started with an engine, then figured out where to bolt a motor onto it. Then, after 2022, BYD did something almost no other automaker on the planet has been willing to do. It completely stopped producing pure gasoline cars. No hedging, no legacy lineup quietly generating cash in the background. Everything after that point was either fully electric or a plug-in hybrid, which meant every engineering dollar, every factory line, and every supplier relationship got pointed at those two categories exclusively. That's a genuinely radical move when you think about what it costs. Most legacy automakers keep their gasoline lineup running, specifically because it funds the electric transition. The profitable trucks and sedans pay for the R&D on the electric models that aren't profitable yet. BYD walked away from that safety net entirely and bet the company on the transition working. Toyota, by comparison, still sells millions of conventional and hybrid gasoline vehicles a year and treats that as a deliberate strategy. Both approaches are defensible, but only one of them forces every single person in the company to get very good at electrified powertrains very quickly, because there's no fallback product line to retreat to if it doesn't work. Here's the root cause underneath everything else in this video. BYD's advantage isn't a single breakthrough component. It's vertical integration. The company builds the engine block, winds the electric motors, assembles the blade battery packs, and fits the gearboxes, all under its own roof. Through its subsidiary Fine Dreams Powertrain. Most automakers buy an engine from one supplier, a battery from another, and a motor from a third, then spend enormous engineering effort making three companies' parts talk to each other. BYD skipped that entire problem by owning all of it. That's the whole mechanism, and every number in this video traces back to it. That vertical integration runs across roughly 8 to 9 major production bases in China. Shenzhen is the headquarters and the R&D center, where new ideas get tested before they scale. Zhengzhou is the mega factory, the one people describe as feeling less like a plant and more like a city, with extremely high automation running day and night. The Xi'an plant handles roughly 900,000 vehicles a year in capacity, building engines and complete systems for hybrid SUVs and sedans. Changsha, in Hunan province, runs a strong hybrid production line known for its skilled workforce. And Hefei is the newest of the group, growing fast. Together, BYD's total vehicle manufacturing capacity inside China alone sits somewhere north of 5 to 6 million cars per year, and it's still climbing. So let's actually get into how one of these powertrains gets built, because the process explains the price better than any spec sheet does. It starts with raw material, steel, aluminum, and alloys arriving at the plant. Then casting and forging, molten metal poured into molds to form the basic engine block shape, and heavy pressure applied to strengthen the metal for the components that take the most stress. From there, the rough block goes to CNC machining, computer-controlled equipment that bores the cylinders, smooths the surfaces, and cuts the holes to tolerances a human machinist can't hold by hand. Pistons, crankshaft, and connecting rods get prepared alongside it. Precision matters more here than it would in a conventional engine, and this is a detail worth sitting with. In a normal car, the engine just has to run well on its own. In a hybrid, the engine has to stay in perfect timing with an electric motor that's constantly handing power back and forth. So a tolerance error that a gas-only engine would shrug off can disturb the entire system's coordination. Then assembly begins, pistons into cylinders, crankshaft installed, then valves, camshaft, and timing chain added in sequence, with oil channels and cooling jackets verified along the way to prevent overheating. Robots and workers share this stage, with the automation handling the repetitive precision work. Next comes the part that actually differentiates BYD's system, the A's unit, the electric hybrid system. Both the drive motor and the generator motor sit inside the same housing, built on their own dedicated line where the motor windings get wound, the magnets get fitted, and the cooling system gets prepared. That unit then connects to the engine, along with a reducer gearbox, an inverter, and a controller. What comes out the other end is a single compact powertrain, engine, 2 motors, inverter, and controller that fits neatly under a car rather than sprawling across the engine bay as separate assemblies. The blade battery arrives from a separate plant as cells, gets assembled into modules and packs, goes through safety testing, and then gets electrically connected to the powertrain along with the battery management system that protects it from overheating and overcharging. And then, everything gets tested before it's allowed to leave. Bench testing runs the engine across different speeds to measure fuel use, power output, and heat generation. Durability testing runs it for extended periods to check strength. Vibration, noise, and emissions get measured, and the ES unit gets its own separate electrical testing. Anything that fails goes back for rework. Only powertrains that pass everything move forward to get mounted on a chassis, dyno tested, water leak tested, software updated, and finally delivered. And that brings us to the thing that actually forced this video, the numbers this system produces. BYD has built more than 7.7 million plug-in hybrids since that 2008 F3DM. In 2025 alone, the company produced and sold more than 4.6 million new energy vehicles across EVs and hybrids combined, and in a number of individual months, the hybrids actually outsold the pure EVs. Back in 2021, a single DMI powertrain line had a capacity around 500,000 units per year, and that was one line years ago. Multiple lines now run at multiplied capacity. Reports have put automation on some BYD lines around 97%, meaning quality checks themselves are largely automated, with cameras and laser sensors scanning parts and flagging defects instantly. Across the major plants, automation levels are described as above 90%, with one worker monitoring several robots at once. BYD also uses digital twin technology, building a virtual model of a real machine in software and running tests on the virtual version before physical production starts, which catches problems before they waste material and line time. Testing data streams to the cloud in real time, and if something looks wrong, the line stops immediately rather than producing a run of flawed units. To put that Zhengzhou operation in perspective, it's been described as substantially larger than a Tesla gigafactory, with robots, conveyor belts, and workers running continuously around the clock. At a car every 30 to 60 seconds, that's well over 1,000 vehicles a day from a single site, and every one of them either arrives with a hybrid system already installed or gets one fitted during assembly. FinDream's powertrain runs dedicated lines for each major component: the hybrid engines, the ACE units combining motor and generator, the gearboxes, and the battery packs, feeding into that final assembly at matching speed. That coordination is the hard part. Building one component quickly is straightforward. Building 4 different component families quickly enough that none of them ever becomes the bottleneck on a line moving a car per minute is a genuinely difficult manufacturing achievement. And it's the part competitors would struggle most to copy even with unlimited capital. But manufacturing scale alone doesn't explain why anyone buys these cars. So let's talk about how DMI actually drives, because this is where BYD genuinely diverges from Toyota. In most traditional hybrids, the gasoline engine is the primary power source and the electric motor assists it. BYD inverted that. In DMI, the electric motor is primary, the car runs on electricity most of the time, and the engine intervenes only when needed, usually as a generator rather than driving the wheels directly. In EV mode, with a charged battery, the car runs purely on the motor, and BYD's figures put that at roughly 80 to 100 kilometers of city driving without touching gasoline at all. In hybrid mode, once the battery runs low, the engine starts, but it doesn't drive the wheels. It spins a generator which feeds electricity to the motor or recharges the battery, and critically, it runs at its most efficient RPM the entire time, rather than constantly changing speed to match your right foot. That's where the fuel savings actually come from. In parallel mode, when you need sudden power for overtaking or hard acceleration, the engine and motor work together to deliver full output. The engine at the center of this is BYD's 1.5-liter Xiaoyun unit, running around 43% thermal efficiency, meaning 43% of the energy in the fuel gets converted into useful work instead of being wasted as heat. For context, a typical conventional gasoline engine sits well below that. The electric motor, meanwhile, runs around 97% efficient. Pair a very efficient small engine with a very efficient motor, and let software decide which one handles each moment. And the results follow. City fuel consumption around 4 to 5 liters per 100 kilometers, sometimes lower. With combined range on a full tank and a full charge, landing somewhere around 1,000 to 2,000 kilometers. On some models, like the BYD Chinel DM-i, claims push past 2,000 kilometers. Compare that directly to Toyota's approach, and the contrast is clear. Toyota's hybrid system is genuinely reliable, that reputation is earned over decades and isn't in dispute. But its architecture is older, with the engine doing more of the work and the motor assisting, which means the engine cycles on and off repeatedly even in city driving. BYD's setup uses a smaller, more efficient engine, a more powerful motor, and a bigger, more advanced battery, which delivers a more EV-like experience with less engine intervention. And the practical appeal of that combination is worth spelling out, because it's the reason these cars sell in markets where pure EVs still struggle. You get the driving character of an electric car, instant torque, no gear change jerk, a quiet cabin, silent crawling through city traffic, without the range anxiety, because there's a gas tank sitting right there. You can refuel at any gas station in any country in a few minutes, or you can plug in at home and never touch gasoline for your daily commute. The software handles the decision automatically, choosing modes based on driving conditions without the driver having to think about it. And because the engine runs far less often than in a conventional car, maintenance costs drop too. Less wear. Fewer cycles, less time under load. That's the specific value proposition that makes DMI so effective in developing markets. In countries where charging infrastructure is still thin, a pure EV asks a buyer to trust a network that might not exist on their route. A DMI car asks them to trust nothing. It works as an EV where charging exists, and as an efficient gas car where it doesn't. That flexibility is worth more to a huge share of the global car buying public than another 100 kilometers of pure electric range would be. And BYD's expansion reflects that. It's assembling vehicles in Brazil, running production in Thailand and Uzbekistan, and building new plants in Hungary and Turkey, though the core hybrid engines and powertrains still come from China, where the infrastructure and scale are concentrated. The roadmap from here escalates further. BYD has said new DMI generations will push range and efficiency higher still, with driving distances above 2,000 kilometers becoming standard rather than a headline claim on one model. The engine gets smaller and more efficient, the motor more powerful, and over-the-air software updates keep improving existing cars after they're sold. There's flex fuel engine work underway for markets like Brazil, where ethanol gasoline blends are common. Advanced driver assistance and Level 2+ autonomy features are coming to the hybrid lineup. And AI-based energy management is being developed to make the engine versus battery decisions smarter, based on real driving conditions rather than fixed rules. Now the honest objection, because vertical integration is a strength right up until it becomes an exposure. BYD's advantage depends on controlling its own supply chain, but it doesn't control the global price of lithium, nickel, and cobalt. And those materials swing hard on international markets. Domestic Chinese supply is strong, but trade restrictions or political friction at the global level could still create real problems for a company this dependent on materials that cross borders. BYD is hedging, working with multiple suppliers, moving into mining in some places, and recycling old batteries to recover materials. But hedging isn't the same as immunity. There's also a genuine limitation in the overseas expansion story. Those plants in Brazil, Thailand, Uzbekistan, Hungary, and Turkey are largely assembly operations right now. The engines and powertrains, the components that actually carry the technological advantage, still ship from China. So the manufacturing efficiency this whole video is built around doesn't fully transfer to those markets yet, and until local engine production actually starts, BYD's cost advantage abroad is smaller than its cost advantage at home. And the automation numbers deserve a bit of skepticism too. A figure like 97% automation comes from reports about specific lines. Not a uniform standard across every plant and every process, and manufacturers everywhere have an incentive to quote their most impressive line rather than their average one. The scale is genuinely real. The precise percentages are worth treating as a company-friendly framing until independently verified. So here's why this matters even if you never buy a BYD. When one company can build the engine, the motors, the battery, and the gearbox in-house and assemble them into a single unit at this volume, it sets a cost floor that suppliers and assemblers structurally cannot match. Toyota, Tata, Ford, Volkswagen, every one of them buys major components from outside suppliers who need their own profit margin on every part sold. BYD captures that margin internally at every step. That's not a small efficiency. That's a structural pricing advantage that compounds across millions of vehicles, and it's why BYD can offer hybrid technology at prices that pressure competitors who are engineering just as competently but buying their parts retail. The knock-on effect is what to actually watch. If BYD can eventually localize engine production in Brazil, Europe, and Southeast Asia, the way it plans to over the next 2 to 3 years, that pricing pressure lands directly in markets where competitors currently feel protected by shipping costs and tariffs. And every rival watching this now faces an uncomfortable question: match the vertical integration, which takes years and enormous capital, or accept a permanent cost disadvantage on a product category that's clearly not going away. Neither option is comfortable. Building vertical integration from scratch means a legacy automaker would have to buy or build battery plants, motor winding operations, and powertrain assembly lines, while simultaneously managing existing supplier contracts it can't just walk away from overnight. Those suppliers are often decades-old relationships with their own leverage. Meanwhile, accepting the cost disadvantage means competing on brand and reliability against a company that can simply price lower whenever it chooses to. Toyota has the reliability record and the global service network to make that fight for a long time. Companies without either of those advantages are in a much harder spot. There's also a lesson here for anyone shopping for a car in the next few years, which is that the hybrid category isn't the transitional afterthought a lot of coverage treated it as. When the company producing the most new energy vehicles on Earth sees its hybrids outselling its own EVs in certain months, that's a signal about what buyers actually want right now. Not what the industry projected they'd want. Range flexibility, lower running costs, and no infrastructure dependency turn out to be a compelling package, and that package is likely to keep improving in price and capability as more manufacturers get serious about competing in it. And that's really the law underneath this whole story. The company that owns the most steps in its own process wins on price, eventually, even against competitors with better brand recognition and longer reliability records. BYD didn't out-invent Toyota on hybrid engineering. It out-integrated everyone, and then let the manufacturing math do the rest. So here's the actual question, and drop your honest answer in the comments. Is BYD's vertical integration a genuine structural advantage that competitors simply can't replicate fast enough to matter? Or is owning every step a fragility disguised as a strength, where one serious supply disruption or trade restriction hits a company with no external suppliers to fall back on? There are real arguments on both sides, and it's genuinely not settled. Next week's video breaks down which battery chemistries are actually sitting in the cars on lots right now, pack by pack, because that story is just as messy as this one.